Hello, in this lecture we'll find out the radius of a circle. In the drawing we have the right triangle ABC. Inside this right triangle we have this circle, and our mission is to find out the radius of this circle. In addition, we know that this is this is angle ABC that is equal to 90 degrees inside. This is line segment AS that is equal to 1 unit. This is line segment ST that is equal to 4 units in length. This is line segment TC is equal to 2 times cos of 4 units in its length. Repeat again that our mission is to find out the radius of this circle. So first of all, we define the center of this circle, this point as O. And we define the radius of this circle, that is the radius that we are looking for in this lecture, as x. So our mission is to find out the value of x, that is the radius of this circle. In the next step, we join points O and Q together by a straight line. So what is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and then at point Q, that is the point of the circle itself. This is exactly the definition of a radius. Therefore OQ is the radius of this circle that is equal to x according to our definition. You can implement here rule 1. I repeat quickly on rule 1. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle, and we have also, this is tangent AB, that is tangent to this circle here, this point, point M. Point M is the point of tendency of tangent AB with this circle. And we also have the radius OM is equal to R, so the radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to this rule, rule 1. So we can actually implement rule 1 in our drawing. Why? Because in our drawing we have the radius OQ is equal to x, so the radius OQ is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by a straight line. OP is the radius of this circle that is equal to x according to our definition. We have here the radius of P that is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So actually, inside this quadrangle OPBQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total the sum of those 4 angles must be equal to 360 degrees. according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrilateral POBQ to 360 degrees, the missing angle must be equal to 90 degrees in its size. So inside this quadrilateral POBQ, we have 4 right angles, and any quadrilateral that has 4 right angles must be this rectangle flat and square. So we relate to this quadrilateral POBQ as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle POQB, side PO must be equal to the opposite side BQ. But PO equals to X, therefore BQ must be also equal to X because they are equal to each other. Likewise, according to the same rule, in the same rectangle POQB, side OQ must be equal to the opposite side PB. But OQ equals to X, therefore PB must be also equal to X because they are equal to each other. So actually found out that quadrilateral POQB is not a rectangle but a square. Why? Because all of its sides are equal to each other. Each side is equal to X. In the next step, we define this line segment AP as A. And we define this line segment QC as B. Actually, we can implement here rule 10. Repeat quickly on rule 10. According to rule 10 is true in any circle. So in any circle, if AB is any chord in the circle, here we have chord AB, and we have the common sub point P. We joined points P and A together by straight line, and from this common sub point P, we draw perpendicular, we draw tangent PT. Tangent PT is tangent to this circle here at this point T. Point T is the point of tendency of tangent PT with this circle. So in this drawing, if this is the drawing, then the following equation will be true. That PT square will be equal to PA times PB. Again, PT square will be equal to PA times PB. We can actually implement rule 10 in our drawing. In our drawing, we have the common sub point A. From this common sub point A, we have tangent AP. And we also have the extended chord TS touches the common sub point A, so all the requirements of rule 10 are satisfied, and therefore we can implement rule 10. According to rule 10, we get that AP square equals to AS times AT. Again, AP square equals to AS times AT. So I write it down. Repeat again, if we focus on the common sub point A, according to rule 10, we get that AP square equals to AS times AT. AP is A, therefore AP square is A square. And it must be equal to AS. AS is 1 times AT. From the drawing, it is very easy to see that AC in total equals to 1 plus 3. Okay. It equals to 1 plus 3 in total. So we actually found out that according to rule 10, a squared equals to 1 times 1 plus 3. So a squared equals to 1 times 1 plus 3 is 4, so it is 1 times 4, that is 4. So in conclusion, I found out that a squared equals to 4. Here we take out of this equation, and finally we get that a equals to the square root of 4, that is 2. So we actually found out that a equals to 2 units in its length. So writing down, here a equals to 2 units in its length. A is the length of line segment AP, and it is equals to 2 units. In the next step, we'll implement rule 10 of this common external point C. For the common external point C, we have tangent CQ, that is tangent to this circle at point Q, and we also have here the extended chord ST, such as the common external point C. So all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, we get that CQ squared equals to CT times CS. Repeat again, if we focus on the common external point C, according to rule 10, we get that CQ squared equals to CT times CS. CQ is B, therefore CQ squared is B squared, and it is equals to CT. CT is 2 times square root of 3 according to what is given as the question, times CS. CS in total equals to 3 plus 2 times square root of 3. Again, CS in total equals to 3 plus 2 times square root of 3. In conclusion, we have found out that B squared equals to 2 times square root of 3 times 3 plus 2 times square root of 3. We'll open the brackets on this side of the equation, and we get that B squared equals to 2 times 3 times square root of 3 plus 2 times square root of 3 times 2 times square root of 3 equals to 12. Why? Because 2 times 2 is 4, and square root of 3 times square root of 3 is 3, and 3 times 4 equals to 12. So B squared equals to, here we have 12, so we substitute 12 by 9 plus 3 plus 2 times 3 times square root of 3. This expression 9 plus 3 plus 2 times 3 times square root of 3 equals to a squared plus b squared plus 2 times ab. If we just substitute a by 3 and we substitute b by square root of 3, we get that 9 plus 3 plus 2 times 3 times square root of 3 equals to a squared plus b squared plus 2 times ab. But this expression equals to a plus b squared. And therefore, this expression must be also equal to a plus b squared when a equals to 3 and b equals to square root of 3. That is to say, this expression must be equal to a that is 3 plus b that is square root of 3 squared. So those two expressions are equal to each other. Those two expressions are also equal to each other. And therefore, those two expressions must be also equal to each other. Okay, so in conclusion, we found out that b squared equals to 3 plus square root of 3 squared. Here we take a root out of this equation, and finally we get that b equals to 3 plus square root of 3. Square root of 3 equals to 1.732, therefore 3 plus square root of 3 will be equal to 4.732. In conclusion, we found out that b equals to 4.732 units in its length. So write it down in the original drawing. B equals to 4.732 units. That is to say 97 QC that is equal to B according to our definition is equals to 4.732 units. And we already found out that A equals to 2. A is the length of line 70 AP that is equal to 2. In the next step, we will implement the Pythagoras theorem on this right triangle, triangle ABC. Here by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle, triangle ABC is AC, therefore the square of the hypotenuse is AC squared. And it must be equal to AB squared plus BC squared. I repeat again. According to the Pythagoras theorem, in the right triangle ABC, AC squared equals to AB squared plus BC squared. What is the length of AC? From the drawing it is very easy to see that AC in total equals to 1 plus 3, that is 4, plus 2 times square root of 3. So AC in total equals to 4 plus 2 times square root of 3. And therefore AC square must be equal to 4 plus 2 times square root of 3 square. Here, AC square equals to 4 plus 2 times square root of 3 square, and it is equals to AB square. AB, from the drawing it is very easy to see that AB in total equals to 2 plus x or x plus 2. Okay. So AB equals to x plus 2, therefore AB square equals to x plus 2 square. Plus BC square. BC equals to x plus 4.732, therefore BC square will be equal to x plus 4.732 square. In conclusion, we should found out that 4 plus 2 times cos of 3 square equals to x plus 2 square plus x plus 4.732 square. Here we open the brackets on both sides of the equation. We calculate the value of 4 plus 2 times cos of 3 square. That is actually equals to 55.7128, and it is equals to x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 square, x plus 4.732 square equals to x square plus 2 times x square plus 4.732 square. This is actually equals to 22.4918 plus 2 times x times 4.732. This is actually equals to 9.464x. So on this side of the equation we have 55.7128. On the other side of the equation we have here x squared plus x squared is 2x squared, plus we have here 4x plus 9.464x equals to 13.464x, plus we have here 4 plus 22.3918, that equals to 26.3918. So here we subtract 59.7128 from this equation, and here this side of the equation we left with nothing, that is to say 0. On the other side of the equation we have here 2x squared plus 13.464x, and we have here 26.3918 minus 55.7128 equals to minus 29.321. In conclusion, I actually found out that zero equals to 2x squared plus 13.464x minus 29.321. So here we divide this equation, this quadratic equation, by 2, and finally we get that 2x squared over 2 is x squared plus 13.464x over 2 is 6.732x, and we have here minus 29.321 0.321 over 2 is minus 14.66 equals to 0, of course. In conclusion, we actually found out that x squared plus 6.732x minus 14.66 equals to 0. So this is actually a quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 6.732x minus 14.66 equals to 0. So, in our specific quadratic equation, x squared plus 6.732x minus 14.666 equals to 0, the coefficient a equals to 1, the coefficient b equals to 6.732, and finally the coefficient c equals to minus 14.66. And the general formula for the value of x is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So we just have to put the values of a, b, and c for our specific quadratic equation. That is to say, those values a, b, and c, in order to find out the value of the values of x in our specific quadratic equation. That is to say, this specific quadratic equation that is x squared plus 6.732x minus 14.66 equals to 0. So we do it now, and we get that x equals to minus b. B is 6.732, therefore minus b is minus 6.732 plus minus square root of b squared. B equals to 6.732, therefore b squared will be equal to 6.32 squared, that is actually equals to 45.3198 minus 4 times a is 1, so minus 4 times 1 is minus 4 times c. C is minus 14.66, therefore minus 4 times a c is minus 4 times minus 14.66, that is actually equals to plus 58.64 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. In conclusion, I actually found out that x equals to minus 6.732 plus minus square root of, inside the root we have 45.3198 plus 58.64, that is equals to 103.9598. So inside the root we left only with 103.9598 divided by 2. So x equals to minus 6.732 plus minus, and the square root of 103.9598 is equals to 10.196 divided by 2. So here we will have two solutions that are possible for x. A positive solution and a negative solution. The negative solution is an incorrect solution. Why? Because of the fact that x, according to our definition, x is the radius of this circle. And the radius is a length, and the length must be a positive number. Therefore, the negative solution is irrelevant, is incorrect, and we'll focus on the positive solution for x, and the positive solution for x is x equals to minus 6.732 plus 10.196 over 2. 6.732 plus 10.196 equals to 3.464 divided by 2. So actually found out that x equals to 3.464 over 2, that is equals to 1.732. In conclusion, actually found out that the radius of the circle, that is the radius that we are looking for, that is equal to x according to our definition, is equals to 1.732 units. And that is the answer to the question. Repeat again. The radius of this circle x equals to 1.732 units. In the next step, I will summarize the lecture. In this lecture, I found out the radius of this circle. So, in the drawing, we have the right triangle ABC. Inside this right triangle, we have this circle, and our mission is to find out the radius of this circle. In addition, we know that this is angle ABC, that is a right angle. This is line segment AS, that is equal to 1 unit in its length. This is line segment ST, that is equal to 4 units in its length. And finally, this is line segment TC, that is equals to 2 times square root of 4 units in its length. I repeat again that our mission is to find out the radius of this circle that is located inside this right triangle, triangle ABC. So in the first step, we defined the center of this circle, this point as O, and we define the radius of this circle, that is actually the radius that we are looking for in this question, as x. So our mission is to find out the value of x, that is the radius of this circle. So in the first step, we actually joined points O and Q together by straight line. What is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and ends at point Q, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OQ is the radius of this circle, that is equal to x according to our definition. We can implement here rule 1. Why? Because we have here the radius OQ is equal to x, so the radius OQ is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by a straight line. OP is the radius of this circle that is equal to x. Again, we can implement in rule 1, because we have the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So actually, inside quadrilateral OPBQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing fourth angle here must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrilateral OPBQ to 360 degrees, the missing angle must be equal to 90 degrees in its size. So we shall find out that inside this quadrilateral OPBQ we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a left angle, if not a square. So we relate to this quadrilateral OPBQ as a rectangle. And we also know that the opposite sides of rectangle are equal to each other. So in rectangle OPBQ, side OP must be equal to the opposite side QB. But OP equals to x, therefore QB must be also equal to x because they are equal to each other. Likewise, according to the same rule, in the same rectangle POQB, side OQ must be equal to the opposite side PB. But OQ equals to x, therefore PB must be also equal to x because of the fact that those two sides are equal to each other. So I shall find out that this quadrilateral POQB is not a rectangle but a square. Why? Because of the fact that all the sides of this quadrilateral are equal to each other. Each side is equal to x. In the next step, we define the length of this line segment AP as A, and we define the length of this line segment QC as B. Here we implemented rule 10, and quickly rule 10. According to rule 10 is true in any circle. In any circle, if AB is the chord of this circle, and we have the common extent point P. From this common extent point P, we join points P and A, and from this common extent point P, we also draw tangent PT that is tangent to this circle, this point T. So in this drawing, the following equation will be true. That PT square will be equal to PA times PB. Again, PT square will be equal to PA times PB. We can actually implement rule 10 in our drawing, and the common extent point A. Why? Because in this common extent point A, we have tangent AP that is tangent to this circle here, this point P. And we have also the chord TS, or the extended chord TS, touches the common extent point A. So all the requirements of rule 10 are satisfied, and therefore we can implement rule 10. According to rule 10, AP square equals to AS times AT. Again, AP square equals to AS times AT. Repeat again. The common extent point A. According to rule 10, AP square equals to AS times AT. AP is A, therefore AP square is A square. AS is 1, and AT is 1 plus 3. Therefore, AP squared is equal to AS times AT will be equal in total to 1 times 1 plus 3, or a square equals to 1 times 1 plus 3. So a square equals to 1 and 1 plus 3 is 4. So a square equals to 1 times 4, that is 4. A square equals to 4, we took a root out of this equation and finally found out that a equals to the square root of 4, that is 2. So line 7 AP is equal to A is equals to 2. Likewise, we implemented rule 10, and this common example point C. Why you can implement a rule 10? Because of the fact that from this common example point C, we have tangent CQ that is tangent to this circle's point Q, and we also have the extended chord ST, such as this common example point C. So all the requirements of rule 10 are satisfied, and therefore we can implement a rule 10. According to rule 10, CQ square equals to CT times CS. Again, CQ square equals to CT times CS. Okay, again, if we focus on the common standpoint point C, according to rule 10, CQ square equals to CT times CS. CQ equals to B, therefore CQ square is B square. CQ square is B square. CT equals to 2 times square root of 3. Here, CT equals to 2 times square root of T times CS. CS or SC in total equals to 3 plus 2 times square root of 3. Again, SC in total equals to 3 plus 2 times square root of 3. Here, CS equals to 3 plus 2 times square root of 3. So actually found out that according to rule 10, B square equals to 2 times square root of 3 times 3 plus 2 times square root of 3. We open the brackets on these sides of the equation and found out actually that B square equals to 2 times 3 times square root of 3 and plus 2 times square root of 3 times 2 times square root of 3, that is 12. In conclusion, we actually found out that B square equals to 2 times 3 times square root of 3 plus 12. Here we substitute 12 by 9 plus 4, 9 plus 3. Again, we substitute 12 by 9 plus 3. And we found out that B square equals to 9 plus 3 plus 2 times 3 times square root of 3. So this expression 9 plus 3 plus 2 times 3 times square root of 3 is equivalent to the expression a square plus b square plus 2 times ab. If we just substitute a by 3 and b by square root of 3, we get that this expression is exactly equal to 9 plus 3 plus 2 times 3 times square root of 3. But because of the fact that this is an algebraic identity, that is to say this expression a square plus b square plus 2 times ab equals to a plus b square. It means that this expression must be also equal to a plus b square when a equals to 3 and b equals to the square root of 3. Therefore, this expression must be equal to 3 plus square root of 3 square, because a is 3 and b is square root of 3. So this expression equals to 3 plus square root of 3 square. So those two expressions are equal to each other, and those two expressions are also equal to each other. And therefore, this expression must be equal to b square. Okay? So in conclusion, we found out that b square equals to 3 plus square root of 3 square. We took a root of this expression and finally found out that b equals to 3 plus square root of 3. Square root of 3 is 1.732, and therefore 3 plus square root of 3 equals to 4.732. In conclusion, we actually found out that b equals to 4.732. So 97QC is equal to b is equals to 4.732, and we have found out that 97AP is equal to a equals to 2. Now we can implement here the Pythagoras theorem in this right triangle, triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In this right angle triangle ABC, the hypotenuse is AC, therefore the square of the hypotenuse is AC square, and it must be equal to AB square plus BC square. Repeat again, according to the Pythagoras theorem in the right triangle ABC, AC square equals to AB square plus BC square. AC, what is the length of AC? AC in total equals to 1 plus 3, that is 4 plus 2 times square root of 3. So AC in total equals to 4 plus 2 times square root of 3, and therefore AC square equals to 4 plus 2 times square root of 3 square. Repeat again, AC square in total equals to 4 plus 2 times square root of 3 square. And it is equals to AB square. AB equals to 2 plus x, so x plus 2. Therefore AB square equals to x plus 2 square. Yeah. AB square equals to x plus 2 square plus BC square. BC equals to x plus 4.732. Therefore BC square equals to x plus 4.732 square. Repeat again, BC square equals to x plus 4.732 square. So in conclusion, we actually found out that 4 plus 2 times square root of 4 plus 2 times square root of 3 square equals to x plus 2 square plus x plus 4.732 square. And 4 plus 2 times square root of 3 square equals in total to 55.7128. And it is equals to x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 square. X plus 4.732 square equals to x square plus 4.72 square, that is equals to 22.3918, plus 2 times x times 4.72, that is equals to 9.464x. So in this side of the equation we have 55.7128, and on the other side of the equation we have here x squared plus x squared, that is 2x squared. We also have here 4x plus 9.464x, that is equals to 13.464x. And finally we have here 4 plus 22.398 is equals to 26.3918. So we subtracted 59.7128 from this equation. So in this side of the equation we left with nothing, that is to say 0. On the other side of the equation we have here 2x squared plus 13.464x, and we have here 26.3918 minus 55.7128. This is actually equals to minus 29.321. In conclusion, we actually found out that 0 equals to 2x squared plus 13.464x minus 29.321. So this is a quadratic equation. We divided this quadratic equation by 2, and finally found out that 2x squared over 2 is x squared, and 13.464x over 2 is 6.732x, and finally minus 29.321 over 2 is minus 14.66, and it is equals to 0. In conclusion, we actually found out that x squared plus 6.732x minus 14.66 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus 4 of b squared minus 4 times ac over 2a. Another specific quadratic equation, that is to say x squared plus 6.732x minus 14.66 equals to 0. The coefficient a equals to 1. The coefficient b equals to 6.732, and finally the coefficient c equals to minus 14.66. And the general formula for x is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So we just have to put the values of a, b, and c for our specific quadratic equation inside this formula for x in order to find out the value of the values of x for our specific quadratic equation, this specific quadratic equation. We did it and we found out actually that x equals to minus b, b equals to 6.732, therefore minus b equals to minus 6.732 plus minus square root of b squared. B equals to 6.732, therefore b squared equals to 6.732 squared, that is 45.7198 minus 4 times a. A is 1, minus 4 times a times c. A is 1, so minus 4 times 1 is minus 4 times c. C is minus 14.66, so minus 4 times minus 14.66 equals to plus 58.64 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. In conclusion, actually found out that x equals to minus 6.732 plus minus square root of 45.3198 plus 58.64 divided by 2. And 45.198 plus 58.64 equals to 103.9598. So in conclusion, actually found out that x equals to minus 6.732 plus minus the square root of 103.9598 over 2. So x equals to minus 6.732 plus minus and the square root of 103.9598 equals to 10.196 divided by 2. So here we have two solutions that are possible for x. One a positive solution and the second one is a negative solution. Why? Because of the fact that minus 6.732 minus 10.196, it is definitely a negative solution, but the negative solution is irrelevant, is incorrect. We must cancel this negative solution. Why? Because of the fact that x, according to our definition, is the radius of this circle. X as a radius is a length, and the length must be a positive number. Therefore, the negative solution is incorrect solution. So we take into account only the positive solution for x, and the positive solution for x is x equals to minus 6.732 plus 10.196 over 2, and 6.732 plus 10.196 is 3.464. So in conclusion, I actually found out that x equals to 3.464 over 2, and 3.464 over 2 is 1.732. So in conclusion, I actually found out that the radius of this circle that is equal to x according to our definition is equals to 1.732 units. Okay, thank you very much.